So I'm doing standard 1.1. I'm doing question 1.11 from the book. It gives you that half-spin particles are in this state right here. And then the first part asks you to find the possible results of the spin component. And since it's half spin, it can either be positive 1/2 or negative 1/2. And then next it asks to find the probability of it being in each of those spins. So first I found the probability for finding a negative half spin, and this is what the probability looks like. And when you expand that out using our state, this is what it looks like. When you have a positive and a negative in a bracket, they are orthogonal to each other. So this minus and positive is actually 0, whereas when you have a minus and a minus, or if this was a plus and a plus, they would be normalized, which would be 1. So since this is 0, this component goes to 0, where this component is times 1. So then it turns into this. When you find the square root of this, you get this, and it would be negative 25 over 34, since I squared is negative 1, but the absolute value makes it positive 25 over 34. And then when you want to find the probability of getting a positive spin, it's the same thing, only back up here, this would be positive, and this would be positive and negative. And so when you do that, the I times 5 over square root of 34 component cancels out, and you're left with 3 over the square root of 34 squared. And so that turns into just 9 over 34. The part B asks what are the probabilities of finding, or what are the spin probabilities using a S of x, and for each of those the probability is just 1/2. And then part C asks for a schematic diagram. So here's the schematic diagram. Up here is the input function, and as it passes through the z, we get 9 over 34 going up to the z, and then 25 over 34 are going down to the sz minus. And then next, that was for part A. Part B has the x after the sz minus, and then so half coming into the x will go up here and half will go down there.